Hello friends, welcome back my YouTube channel MS Maths. In this video we will discuss about the Laplace transform of the function, a special function, and that function is known as unit impulse function, or this function is also known as Dirac Delta function. Okay, so this is a special type of function and we will discuss about the Laplace transform of this function and what will be the Laplace transform and what is the Laplace transform in a particular case. So we will derive like the formula of the Laplace transform, and basically first of all we will discuss about what is the unit impulse function, what is like delta Dirac function. So first of all what is impulse? So I'm just talking about impulse. So impulse is nothing but basically impulse is nothing but a magnitude. When a magnitude of force, when a magnitude of force is very high, just an instant. So basically the impulse is nothing but a magnitude of force is very high, just an impulse for a little time, for a short time. Force is very high, okay, very high force for just a second. We can't say that a second, like just an instant. Okay, so that is the impulse, and the representation is the representation of this impulse. This impulse is called basically Dirac Delta function. This function is known as Dirac Delta function, and that function and the magnitude of that function of the very high for just an instant. Okay, for an instant, like little time of little period of a time, that is a very short time. Okay, so basically the definition the representation of that function is the delta Dirac function, and it is denoted like this. Okay, t minus a. This is the representation of this function. And what's the definition? So basically definition is nothing but a you can see a graph. First of all we will discuss about the graph and then come to the definition. So basically this is the function, and here it is a function of epsilon. Okay, and this is the time that is on the x-axis. Now I'm taking a point t is equals to a and a point t plus epsilon. So basically the area of this strip is unit. Okay, like the important and the speciality of this function, the area of this strip will be unit. Now if I am taking epsilon tends to 0. Okay, now if I am taking epsilon tends to 0, it means the width of strip decreases. Okay, the width of strip decreases, but still, like if 1 upon epsilon and epsilon tends to 0, it means this term tends to infinite. It means the height of the function tends to infinite. It means the height of the function increases when the epsilon, or when the width of the strip decreases, then the height of the strip will be increases. And this is the speciality of this function. It means the area remain unity. Always, in every condition, the area remains unity, because it adjusts automatically. Because if you are decreasing the width, if you are decreasing the width, but automatically the height will be increasing. The height will be increasing, then it automatically adjusted the area. So basically the area of this strip always unity. So this is the definition. It means when t in between, basically a to a plus epsilon. Okay, epsilon is nothing but a greater than 0, a positive integer basically. So a and a plus epsilon, the area of this strip, that will be the the height of that strip, that will be the 1 upon epsilon. And if epsilon tends to 0, then the height, basically the value is, otherwise the value is 0. Okay, in between, basically you can see in between the value, the height, basically 1 upon epsilon. If the t is less than a, it means here, so it will it lies on the x-axis, it means t is equals to 0 and the function is 0. Outside this function 0 and outside here it is 0. So basically it is the physical the meaning of this function and the importance of this important function, basically the magnitude of high force. So basically impulse, like in this particular range the impulse is 1 upon epsilon. Okay, if the epsilon tends to 0, it means the gap of this strip, the gap of these 2 points remain decreases, but the area remains constant. Okay, so this is the unit impulse function or Dirac delta function. Now come to the Laplace transform of this function. So what will be the Laplace transform? So by using the definition of Laplace transform, that is nothing but a Laplace transform of a function ft is equals to 0 to infinite e to the power minus st ft dt. Okay, now here a function is delta Dirac function. It means 0 to infinite e to the power minus st, okay, minus st delta Dirac function and dt. Now we have intermediate points, 2 intermediate points, then we can easily break the integration, the limit of integration into 2 intermediate points and 3 integration, like 0 to a e to the power minus st and delta Dirac function dt, plus again a to a plus epsilon. It is nothing but a function, like it is a strip, area of a strip, like integration is nothing but area. Okay, so e to the power minus st delta Dirac function dt, and other portion, like one limit is from here to here, 0 to a plus epsilon, a to a plus epsilon to infinite. Okay, so next will be a plus epsilon to the infinite e to the power minus st delta e to the power delta epsilon t minus a dt. So this and this term is 0. Because of that, the definition outside this range, the function will be 0. So it means the value of this function I am writing here. So basically it will be 0 and it will be 0. Now we have to solve this integration, like basically the definition, like the Laplace transform of the delta Dirac function is nothing but a to a plus epsilon and e to the power minus st, and basically in this range the value is 1 upon epsilon. So basically 1 upon epsilon dt. Now 1 upon epsilon is a constant. We can easily integrate this function, like 1 upon epsilon e to the power minus st upon minus s and a to a plus epsilon. And now putting the limit, like putting the limit, it will be e to the power, like we can write s outside, and this is the minus, so minus e to the power minus of s into a plus epsilon, and minus plus e to the power minus as. Now we can take common e to the power minus as upon s tends to finite. This whole function depends on this limit, epsilon tends to 0. So basically if I am taking this here, so it will be the 1 minus e to the power minus s epsilon. So basically on applying the limit, epsilon tends to 0. So basically limit epsilon tends to 0. So e to the power minus as upon s is nothing but we can take outside, or it is s epsilon, and it is as yes, we can take outside, and this will be the 1 minus e to the power minus s epsilon upon s epsilon. Epsilon, only epsilon. But when I am putting the limit here, this will be the 0 by 0 form, 1 minus 1 upon 0, that is the 0 by 0 form, and we can use L'Hopital rule. So basically like L'Hopital, by using L'Hopital rule, so it will be the e to the power minus as upon s. Okay, and this will be the limit, epsilon tends to 0, and the derivative of 1 is 0, and taking the derivative of this is as e to the power minus s epsilon upon 1. The derivative with respect to epsilon, because the limit is epsilon, because we are putting the limit of epsilon. Okay, so now it will be the e to the power minus as upon s. Now putting the limit, so this term will be 1. E to the power 0 is 1. Then this is s, and now by cutting this, e to the power minus s. It means the Laplace of this delta Dirac function is nothing but e to the power minus s. This is the simple form of this, like the Laplace transform of this. If now I'm taking the special case. So basically the Laplace of the delta Dirac function t minus a is nothing but e to the power minus as. But now if a is 0, it means the function started from the origin. It means 0, 0 plus epsilon. The a is 0. It means the strip like this. Okay, this is a and this is 0 plus epsilon. This is nothing but 0 plus epsilon. So basically, for this, if a is 0, then the Laplace transform of the Dirac delta function, that is the e to the power, like it will be 0 and 1. Simple thing is here, the area, like the Laplace of this function will be only just 1. Okay, so this is the all about the Dirac delta function or unit impulse function. I hope you got all the concepts, and I hope you can understand all the concepts by this video. So thanks for watching my video. Keep watching MS Maths, and for these types of video you can subscribe our channel and you can share our channel. So thank you. Bye bye.